have probably experienced waking up on a rainy morning and spending the rest of the day sweating because of the sun's glaring heat. What could be the reason? Could it be the weather? Or could it be the climate? Which one? Good day! I'm Cheldyne Reese Pepito from Grade 9 Cassiopeia, and this is my performance test 2 in Science 9 Module 4. Changes in the atmospheric condition over a brief period of time, such as a day or a week, are weather. The changes that are part of a larger pattern of atmospheric conditions are called climate. Climate is the general pattern of weather that occurs for a region over a number of years. Climate determines what types of houses people build in a particular region, the plants and animals that inhabit in a location, and even the livelihood of the people and community. Both weather and climate are the result of the interaction of several Earth systems. First, the movement of moisture in the water cycle that evaporates ocean water into the air where it condenses into traveling clouds or storms that eventually cause rain or snow. Second, the movement of heat that begins at the sun-soaked equator and moves warm air toward the north and south poles. And third, the movement of the ocean that takes icy water from the poles to the tropics, warming or cooling the air above the water. Those factors include the greenhouse gases in the atmosphere combined to form high and low pressure systems and the climate of the location you live in. To understand the complex interaction and patterns of the weather and climate, scientists collect as much observational data as they can on precipitation, temperature, humidity, and other atmospheric conditions. There are different factors that affect the climate. These are latitude, altitude, prevailing wind, ocean current, and topography. Latitude is the main factor affecting global climate. The further we go from the equator, the temperature drops and the cooler it gets. This is because we know that the Earth is curved, which means that the sun's energy is more concentrated at the equator. This means Earth gets hotter at equator and places near equator. Temperature decreases with increasing altitude at an average rate of 6.5 degrees Celsius for every 1,000 meter increase in altitude, as the atmosphere receives less heat through terrestrial radiation. For this reason, we know that the mountains are always cooler compared to lower places. Prevailing wind or wind directions over a particular location on Earth due to uneven heating from the sun and the rotation of Earth on its axis. The Earth's rotation affects the air moving toward its surface. It is deflected by the Coriolis force to the right in the northern hemisphere, producing polar easterlights to the left in the southern hemisphere. The easterlights are created when the winds blow toward the equator and deflected to the west. The westerlights are created when the wind blows toward the pole and deflected to the east. Ocean currents are the continuous and directional movement of ocean created by friction, water density, Earth's rotation, solar energy, and gravity variation in different parts of the ocean. The direction of water movement is either horizontal or vertical. The ocean current system flow clockwise in the northern hemisphere and counterclockwise in the southern hemisphere in circular patterns. The ocean currents transport warm water and precipitation from the equator to the poles and cold water from the poles back to the equator. This regulates the global climate and uneven distribution of heat reaching Earth's surface. The topography of Earth's surface is one of the factors that affects weather and climate. The difference in elevation and mountain ranges determine the distribution of precipitation on Earth. The bodies of water shape the climate and create the high and low pressure systems that cause weather events. The windward side of the mountain faces the wind and receives warm and moist air. As the wind hits the mountain, the air is forced to move upward along the slope of the mountain and begins to cool due to decrease in atmospheric pressure. The leeward side of the mountain is the opposite side of the windward. The air that goes down the slope has lost its moisture on the windward side, resulting to warm air and low relative humidity.